العالمين.
All right, how about something that's a little more powerful too? We spent so much time in week 0 and 1 doing searching and then eventually sorting in week 3. Well, it turns out Python can help with some of this too. Let me go ahead and create a program called names.py that's just going to be an opportunity to maybe search over a whole bunch of names. Let me go ahead and import sys. And then just so I have access to exit. And let me go ahead and create a variable called names that's going to be a list with a whole bunch of names. How about here? Charlie and Fred and George and Ginny and Percy, and lastly, Ron. So a whole bunch of names here. And, you know, it'd be a little annoying to implement code that iterates over that from left to right in C, searching for one of those names. In fact, what name? Well, let's go ahead and ask the user to input the name that they want to search for so that we can tell them if the name is there or not. And we could do this similar to C in Python, doing something like this. So for n in names, where n is just a variable to iterate over each name, if how about the name I'm looking for equals the current name in the list, aka n, well, let's print out something friendly like found. And then let's do sys.exit0 to indicate that we found whoever that is. Otherwise, if we get all the way to the bottom here outside of this loop, let's just print not found, because if we haven't exited yet, and then let's just exit with 1. Just to be clear, I can continue importing all of sys, or I could do from sys import exit, and then I could get rid of sys dot everywhere else. But, you know, sometimes it's helpful to know exactly where functions came from. So this, too, is just a matter of style in this case. All right, so let's go ahead and run this. Python of names.py. And let's look for, like, Ron all the way at the end. You know, all right, he's found. And let's search for someone outside of the family here, like Hermione. Not found. OK, so it seems to be working in this way. But I've essentially implemented what algorithm? What algorithm would this seem to be per line 7 and 8 and 9 and 10? Yeah, so it's just linear search. It's a loop, even though the syntax is a little more succinct today. And it's just iterating over the whole thing. Well, honestly, we've seen an even more terse way to do this in Python. And this, again, is what makes it a more pleasant language sometimes. Why don't I just do this? Instead of iterating one at a time, why don't I just say this? Let me go ahead and change my condition to just be, how about if the name we're looking for is in the names list, we're done. We found it. Use the in preposition that we've seen a couple of times now that itself asks the question, is something in something else? And Python will take care of linear search for us. And it's going to work exactly the same. If I do Python of names.py, search for Ron, it's still going to find him. And it's still going to do it linearly in this case. But I don't have to write all of the lower level code myself in this case. Questions now on any of this? The code's just getting shorter and shorter. Now, what about, let's see, what else might we have here? How about this? It turns out, let's go ahead and implement that phone book that we started metaphorically with in the beginning of the course. Let's code up a program called phonebook.py. And in this case, let's go ahead and let's create a dictionary this time. Recall that a dictionary is a little something that implements something like this, like a 2-column table that's got keys and values, words and definitions, names and numbers. And let's focus on the last of those, names and numbers in this case. Well, I claimed earlier that Python has built-in support for dictionaries, dict objects that you can create with one line. I didn't need it for Speller because a set is sufficient when you only want one of the keys or the values, not both. But now I want some names and numbers. So it turns out in Python, you can create an empty dictionary by saying dict open parenthesis close. And that just gives you essentially a chart that looks like this with nothing in it. Or there's more succinct syntax. You can alternatively do this with 2 curly braces instead. And in fact, I've been using a shortcut all this time. When I had a list earlier where my variable was called scores, and I did this, that was actually the shorthand version of this. Hey, Python, give me an empty list. So there's different syntax for achieving the same goal. In this case, if I want a dictionary for people, I can either do this or, more commonly, just 2 curly braces like that. All right, well, what do I want to put in this? Well, let me actually put some things in this. And I'm going to just move my close curly brace to a new line. If I want to implement this idea of keys and values, the way you do this in Python is key, colon, value. comma, key colon value. So you'd implement it more in code. So for instance, if I want Carter to be the first key in my phone book, and I want his number to be +1 617 495 1000, I can put that as the corresponding value. The colon is in between. Both are strings or strs, so I've quoted both deliberately. If I want to add myself, I can put a comma. And then just to keep things pretty, I'm moving the cursor to the next line. But that's not strictly required aesthetically. It's just good style. And here I might do +1 949 468 2750. And now I have a dictionary that essentially has two rows here, Carter and his number, and David and his number as well. And if I kept adding to this chart would just get longer and longer. Suppose I want to search for one of our numbers. Well, let's prompt the user for the name for whose number you want to search by getting string. Or you know what? We don't need the CS50 library. Let's just use input and prompt the user for a name. And now we can use this super terse syntax and just say if name in people print the formatted string number, colon, and here we can do this, people bracket name. OK, so this is getting kind of cool, kind of quickly, kind of confusingly. So let me run this. Python of phonebook.py. Let's type in Carter, and indeed I see his number. Let's run it again with David, and I see my number here. So what's going on? Well, it turns out that a dictionary is very similar in spirit to a list. It's actually very similar in spirit to an array in C. But instead of being limited to keys that are numbers, like bracket 0, bracket 1, bracket 2, you can actually use words. And that's all I'm doing here on line 8. If I want to check for the name Carter, which is currently in this variable called name, I can index into my people dictionary using not a number, but using literally a string, the name Carter or David or anything else. To make this clearer too, notice that I'm at the moment using this format string, which is adding some undue complexity. But I could clarify this perhaps further as this. I could give myself another variable called number, set it equal to the people dictionary, indexing into it using the current name. And now I can shorten this to make it clearer that all I'm doing is printing the value of that. And in fact, I can do this even more cryptically this would be weird to do, but if I only ever want to show David's phone number and never Carter's, I can literally, quote unquote, index into the people dictionary. Because now when I run this, even if I type Carter, I'm going to get back my number instead. But that's all that's happening if I undo that, because that's now a bug. But I index into it using the value of name. Dictionaries are just so wonderfully convenient because now you can associate anything with anything else, but not using numbers, but entire keywords instead. So here's how if in Speller we gave you not just words, but hundreds of thousands of definitions as well, you could essentially store them as this. And then when the human wants to look up a definition in a proper dictionary, not just for spell checking, you could index into the dictionary using square brackets and get back the definition in English as well. Questions on this? Yeah?
Is the way that this code does it, because I know you're saying that Python has functions already made for you, is the in preposition actually iterate through an array to find the value? Or because you're calling the value here, it must still find a way to go to location and find it?
A really good question. So to summarize, how is Python finding that name within that dictionary? This is where, honestly, Speller in pset 5 is what Python's all about. So you are struggling with implementing your own spell checker and implementing your own hash table. And recall that per last week, the goal of a hash table is to ideally get constant time access, not something linear, which is slow, and even better than something logarithmic like log base 2 of n. So Python and the really smart people who invented it, they have written the code that does its best to give you constant time searches of dictionaries. And they're not always going to succeed, just as you in your own problem set probably going to have some collisions once in a while and start to have chains of linked lists of words. But this is where, again, you defer to someone else, someone smarter than you, someone with more time than you to solve these problems for you. And if you read Python's documentation, you'll see that it doesn't guarantee constant time, but it's going to ideally optimize the data structure for you to get as fast as possible. And of all of the data structures, like a dictionary, a hash table is really like the Swiss Army knife of computing, because it just lets you associate something with something else. And even though we keep focusing on names and numbers, that's a really powerful thing, because it's more powerful than lists and arrays, which are only numbers and something else. Now you can have any sorts of relationships instead. All right, let me show a few other examples before we culminate with some more powerful techniques in Python thanks to libraries. How about this problem we encountered in week 4, which was this? Let me code up a program called, again, compare.py here. But this time, compare two strings and not numbers. So let me, for instance, get one string from the user called s. Just for the sake of discussion, let me get another string from the user called t, so that we can actually do some comparison here. And if s equals t, let's go ahead and print out that they're the same. Else, let's go ahead and print out that they're different. So this is very similar to what we did in week 4. But in week 4, recall, we did this specifically because we had encountered a problem. For instance, if I run, whoops, if I run, what's going on? Input t. Come on. Oh. OK, wow, OK, long day. All right, if I run the proper command, Python of compare.py, then let's go ahead and type in something like cat in all lowercase, cat in all lowercase, and they're the same. If, though, I do this again with dog and dog, they're the same. And of course, cat and dog, they're different. But does anyone recall from 2 weeks ago when I typed in my name twice, both identically capitalized, what did it say? That they were, in fact, different. And why was that? Like, why were two strings in C different, even though I typed literally the same thing? Two different places in memory. So each string might look the same aesthetically, but of course was stored elsewhere in memory. And yet Python appears to be using the equality operator, equals, like you and I would expect as humans, actually comparing for us char by char in each of those strings for actual equality. So this is a feature of Python in that it's just easier to do. And why? Well, this derives from the reality that in Python there are no pointers anymore. There's no underlying memory management. It's not up to you now to worry about those lower level details. The language itself takes care of that for you. And so similarly, if I do this and don't ask the user for two strings, but just one, and then I do something like this, how about give myself a second variable t, set it equal to s.capitalize, which note is not the same as upper. Capitalize by design per Python's documentation will only capitalize the first letter for you. I can now print out, say, two f strings here, what the value of s is. And then let me print out with another f string what the value of t is. And recall that in C, this was a problem because if you capitalize s and store it in t, we accidentally capitalized both s and t. But in this case, in Python, when I actually run this and type in cat in all lowercase, the original s is unchanged. Because when I use capitalize on line 3, this is indeed capitalizing s, but it's returning a copy of the result. It cannot change s itself because, again, for that technical term, s is immutable. Strings, once they exist, cannot be changed themselves, but you can return copies and modified, mutated copies of those same strings. So in short, all of those headaches we encountered in week 4 are now solved really in the way you might expect. And here's another